Hey everyone, I just want to warn you that I was playing around with some of the settings before I started this video, and I found out that the laser pointer can be a lightsaber. So there's no way, this is not going to be used all the time in every video, so I'm apologizing now. Anyway, let us get started on some math with inverse trig. We're still working on evaluating. And this is day 4. So some of what we're doing is going to be on the test, things that you need to know. However, the last example we do will not be. So I'm going to repeat that again later in the video, but just to let you know. So please make sure you watch day 3 before you continue on here, because I'm not going to go over all of the restrictions again. But just make sure you go back and watch that. We're just going to get started with what we can do. So first example is going to be cosine of tangent inverse of 50. And you may be like, Miss Twain, that's not a thing. That's just a number. You are correct. What if I made it 50 over 1? You may still say, yeah, that's not something that's on the unit circle. Let's make notes over here. So let's see, since 50 over 1 is not a tangent ratio, so something we may recognize from the unit circle like root 3 over 3 or 1 or root 3, something like that. Since it's not any of those, from the unit circle, we need to find another way to evaluate. So we need to find another way to evaluate. So we think, well, triangles are a thing. And we can say that the ratio of 50 over 1, just a reminder, you can take any number, stick it over 1, it's a fraction. For tangent, the TOA of our SOHCAHTOA is going to be opposite over adjacent for our angle theta, whatever that may be. So I take a look at this. I know that tangent and tangent inverse are both positive in quadrant 1. So we're going to draw something in quadrant 1. Move this up just a little bit. So let's see, if I was to draw a thing, let's draw in vibrant green. I love this color. This is one of my favorite colors, actually. All right, so let's see, we have triangle. We're going to pretend like this is to scale because we all know it is not. Okay, we got an angle here. My opposite side over here is going to be 50. My adjacent side is going to be 1. Again, yes, I know, not drawn to scale. And we are looking for whatever that is right there. So now the overall goal is, I'm going to write this in blue, is to find cosine of whatever this angle is, because we're saying, well, we need to find that angle, but we need to remember that that angle is going to be tangent inverse of 50 over 1. So if we take this particular section, where's my highlighter? We take this section from our problem above. Ooh, that was skinny. That tangent inverse of that is our theta. That's kind of the composition and the composition function. So we need to find that. I'm gonna go. I almost wrote in highlighter. Come on, there we go. So now what we need to do, I actually wanted the blue pen, is in order to find cosine, we need the hypotenuse. So let's try and find that. So using some mathy skills, we'll do that in green. We can say that, 50 squared plus 1 squared is equal to r squared. 2500 plus 1 is equal to r squared. That's not how math works. There we go. That's how math works. 2501 is equal to r squared. And then when I take the square root of both sides, normally when we do square root, it is plus or minus. However, here, since we are looking at a distance of something, we're just going to keep the positive version. We're going to say that r is equal to the positive square root of 2,501. So that seems kind of crazy. So when I start working here, and remember we said we needed to find the cosine of this, so I can say cosine of theta is equal to opposite, oh goodness, not opposite, pardon me, adjacent 1 over hypotenuse square root of 2,501. Now that is not great. Let's rationalize that. Okay, and that is going to get us the square root of 2,501 over 2,501, and as gross as that looks, that's our final answer. So we can say that the final answer to our problem is cosine tangent inverse of 50 is equal to the square root of 2,501 over 2,501. So really what I'm doing is I'm either using the ratios that I know, or I'm saying, hey, what's going on here? Can I draw a triangle to figure this out? Sometimes you'll need to draw a triangle, but not always. And we'll get back to that in just a little bit, but first you may have noticed I haven't done a single problem yet with cosecant, secant, or cotangent. So let's take a quick break from our triangle drawing, do just a couple of those. I promise those go by pretty fast, and then we'll get back into drawing our triangles. So let's move on here. So just to remind you from our SOHCAHTOA, sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Well, we know that their reciprocals are just 1 over this thing or the flip. So we can say that, I do not know what just happened. Cosecant of theta is equal to the hypotenuse over opposite. Secant of theta is equal to hypotenuse over adjacent. And cotangent of theta, we're just going to undo that. Where's my undo? There we go. Whatever. Cotangent of theta is equal to adjacent over opposite. So these are all of our ratios. And remember, they are truly just the flip of these. So for instance, if I gave you a problem of cosecant inverse of 2, you might be like, I have no idea what that is. What is that ratio? Well, cosecant of 2 is really cosecant of 2 over 1, which is our hypotenuse over opposite. So if I was to flip that, I can really say this is the same thing as sine inverse of that flip, or that reciprocal, of 1 over 2, giving us that opposite over hypotenuse. This works because they have the same restrictions, because they are the reciprocal of the same function. So taking a look at this, sine inverse of 1/2. So I'm looking, if you remember our circle, looking for this information here. Sine of 1/2 is going to be happening right here at pi over 6. So we can say the cosecant inverse of 2 is pi over 6. So again, hoping that that wasn't too bad. Should be pretty quick. If you've watched the previous video, this will make a lot more sense. Let's try another. Okay, let's see. If we take a look at problem number 2, what if we did secant inverse of 0? Okay, well, let's see. Let's stick that over 1. Secant, I'll move this back down, and we're going to use the lightsaber. Haha, for right here. Oh, this is weird to point with. Okay, well, I'm pointing right here at my secant. We know this is hypotenuse over adjacent. Hypotenuse over adjacent. So we're going to flip this over, or find its reciprocal to find something that we recognize. So this is really going to be cosine inverse of 1 over 0, or adjacent over hypotenuse. Only problem with this is you can't divide by 0. That's really bad. Don't do that. So here, our answer is undefined. So it is possible to have undefined or no solution or something like that. So just keep in mind, if you're finding things getting weird, this may be a possible answer. So let's see. Let's try another one. This one will have an answer, I promise. So we're going to mix it up. We're going to take everything we've been learning and bring it all together. So our third example is going to be sine of secant inverse of 4. Okay, so remember this 4 is really a 4 over 1. So I'm going to flip this section right here. I'm going to make this bigger. There we go. I'm going to flip this section right here so it's something I recognize from the unit circle. So we're going to say this is really sine of cosine inverse of 1 over 4. So I look at this and I'm like, okay, 1 over 4, not something that I recognize. Let's draw this as a triangle. So if I was to draw this as a triangle, we're going to just draw this in quadrant 1. Every problem I give you is going to be a quadrant 1 triangle. Normally I'd give you others, but right now, don't worry about it. So this is going to be boop, quadrant 1, theta. There we go. So let's see. Cosine, as we've already said, is adjacent over hypotenuse. So let's see. Our adjacent side is 1. Our hypotenuse is 4. We need to know what this other side is. So we're going to use Pythagorean theorem to help us out. Let's see. Let's call this b. So let's see, 1 squared plus b squared gives you 4 squared. 1 plus b squared is equal to 16. A squared is equal to 15. Square root both sides. You get b is equal to the square root of 15. Okay, I'm going to erase this b right here and say that that is the square root of 15. So now remember when we're doing this, that cosine inverse of 1/4, this is really our theta. So if I was to ask you, what is sine of theta, because these are composition functions, what is sine of theta? Well, that's going to be our opposite over our adjacent, or in this case, square root of 15 over 4. And there you go. So when we rewrite our final answer, we're going to say that sine of secant inverse of 4 is equal to the square root of 15 over 4. Hopefully this is starting to make a little bit more sense. We'll do one more that is something that you are going to need to know, and then we'll do another problem just for fun and for just good to knows. Let's do one more here. Looks like a little bit more. So let's see, we'll do problem number 4. This is going to be cosecant inverse of 2 root 3 over 3. So cosecant, okay, if I find the flip or reciprocal of this, it's going to be sine inverse of 3 over 2 times the square root of 3. Now, okay, this is something you're like, not on a unit circle. I'm going to draw a triangle of this. You totally can, but maybe try rationalizing it first. So you can draw a triangle. But try rationalizing first. The reason you might want to do that is because it may make your life just a whole lot easier. So let's see, if we take 3 over 2 times square root of 3, we multiply top and bottom by the square root of 3. Let's see, we are going to get 3 times the square root of 3 over 2 times 3. And it's like, hey, those 3's cancel out. And I'm just left with the square root of 3 over 2. And I'm like, oh, I know that one. That's a thing that I know. So what we're really saying, so this is really sine inverse of root 3 over 2. Now if I was to draw the circle for this, again, here's where I'm looking for sine. When sine is root 3 over 2, that's going to be roughly right there at pi over 3. So our whole answer of cosecant inverse of 2 square root of 3 over 3 is pi over 3. Look at all that learning we just did. So this is going to be the end of everything you need to know for the test that is coming up next week. So this is the end of everything you need to know for the test coming up next week. If you have any questions, come say hi to me in a Zoom chat or send me an email. Please let me know if I make a mistake on the Go Formative homework. I've yet to post one that did not have a typo in it, so please go through that with a fine-tooth comb. The next example we do, we're only going to do one more. It's not something that's on the test, but just maybe something fun to know. It does use trig identities, which is something we have cut, but it's something you should know from our last unit. Also, at this time, the special password keyword for the day is hootenanny. So the special word of this lesson is hootenanny. I know many of you type that to me in messages. I don't know how to spell that, and I would say Google it, but if you can't spell it, it's difficult to Google. So good luck with that. This is the word I want you to tell me on Wednesday or Thursday, depending on whether you're an A-day person or a B-day person, but the word is hootenanny. All right, last example. Let's do this. Come on, keep going. Boop. Okay, so our example, last one, is going to be cosine of sine inverse of 3/5 minus cosine inverse of 12/13. And you may look at this and be like, what? Miss Twain, why? Well, what this really is if you think, this is a sine inverse here, where's my lightsaber? Sine inverse here. This is really theta is equal to this thing. So let me get out color. Let's do red. So it's really, oh, that's a highlighter. Goodness gracious. Okay, we're just gonna, boop. Okay. Sorry, my bad. Theta is equal to sine inverse of 3/5. That's really the angle in there. And then over here for our cosine, we'll do that one maybe in yellow. This is really, we'll say alpha. Got to use another letter. Alpha is really equal to cosine inverse of 12 over 13, because that's the angle for a different triangle. So these are two different angles. Well, instead of calling them theta and alpha, what if I called them A and B? So if I was to simplify this, this would really be cosine of A minus B. Oh, I recognize that. That's a thing that we know. Okay, so what I need to do is I need to find out the shenanigans that are going on for cosine A, cosine B, because we eventually want to use, or not, pardon me, not cosine A, cosine B, our ratios that we need to use, because we eventually want to use our cosine difference identity. I'll rewrite this down below, but it is cosine of A times cosine of B plus sine of A times sine of B. So I have to set up both of these triangles, find their ratios, plug this into this identity. So let's do that. So let's see, for our theta, or we can just call it angle A. Again, everything's going to be in quadrant 1. So it's going to be our angle A. We know that our sine, which means opposite, is going to be 3. Hypotenuse is going to be 5. If we use our Pythagorean theorem, or if you just know your Pythagorean triples, you know this side here will be 4. So we can say that sine of A is 3 over 5, something we already knew. Cosine of A is 4 over 5. And tangent of A, oops, nope, looking at the wrong thing. Where's the back? There we go. Is 3 over 4. So here's everything we know for that. For our alpha, or angle B, yeah, that's roughly to scale. All right, so our angle B right here, we know cosine is adjacent over hypotenuse. This will be 12, 13. And then you can use Pythagorean theorem, or just know your Pythagorean triples that our opposite side here is going to be 5. So we can say that sine of our angle B is 5 over 13. Cosine of our angle B is 12 over 13, something we already knew. And tangent of angle B is going to be 5 over 12. So when we plug everything into this identity up here, let's see what we can do. So I'm going to rewrite the identity again. Cosine of A minus B is equal to cosine of A times cosine of B plus sine of A times sine of B. Let's see, it's going to be equal to cosine of A 4/5 times cosine of B 12/13 plus sine of A 3/5 over sine of B 5/13. So let's see, if we multiply straight across, we get 48 over 65 plus 15 over, I don't know how that became a 16, there we go, 15 over 65. When I add these two together, I end up with 63 over 65. And that's going to be my final answer. So we can say that cosine of sine inverse of 3/5 minus cosine inverse of 12/13 is in fact 63 over 65. Woo! Okay. We did it! Yay! Thank you if you've stuck around this long. I know we're going into our second week of distance learning. I just want to say that you all are doing great. Anything you can do is something, and I appreciate that. Take a moment for yourself this week. Take some deep breaths. You're going to be okay. I look forward to seeing you soon.